Okay, the last question for this week is question number 5. So question number 5 is, again, we are testing you chapter 5, circular motion. So in this case, we have a particle moves in a horizontal circle, okay, of radius 15. So this is our particle. Okay, it moves in horizontal circle, okay, inside an inverted smooth hollow hemisphere. So you can imagine hemisphere like a bowl. Okay, calculate the speed. So we are given the radius and we are given the speed. If you or you may look at this to get a clearer understanding or imagination on how the particle is moving. So this is the motion of the particle. Okay, it is moving in circular motion. Okay, so based on this, we have the radius is here. Okay, if you have a bigger picture, so the particle is here and the particle is making circular motion, and this is our centripetal force. So in this case, we need to find the velocity. So the question, okay, is a long way on how to solve the question. So let us first draw the free body diagram for the particle. So basically we have weight acted on the particle and also normal. Okay, normal is always 90 degree to the surface. This is the surface. So that's how our normal is acted in this direction. It is not straight upward. Okay, it is in this direction. So our free body diagram is like this. So we have W, we have normal. Okay, we have normal. And also here we have, this is not included in the free body diagram, but we want to know that this is our direction of centripetal force. So for this case, to find the velocity, we are using x-axis and also y-axis. Okay, so for x-axis, we have summation of fx is equal to fc. Okay, so meaning that you need to resolve our n, and normal here we need to resolve to n y and also n x. Okay, so basically in our case, our n x is contributing to our centripetal force, and let's say the angle is here. Okay, so the angle is here. Basically your angle is, okay, if you refer this diagram, so this is your n, your angle, this is your ny, your angle here is equal to this angle. So we'll find out the value of angle later. Now we have nx is equal to n sine theta. Okay, fc is equal to mv squared over r. So this is our first equation. Okay, so we are not given the value of mass. Okay, we're not given the value of normal. So first we try to do both for x and y axis. So for summation of fy is equal to 0 for y axis. So in this case, for y axis we have normal and weight. So it's normal ny minus w is equal to 0. Then ny is equal to n cos theta equal to weight mg. Now this is our second equation. To simply solve the question, we divide our equation number 1 with equation number 2. Then you'll see that we can cancel out so many quantities. So it makes us easier to solve this question. Okay, right side is mv squared over r divided by mg. So now we have n can be cancelled out, mass can also be cancelled out. Then finally you have sine our cos is tangent theta, and our right side is v squared over rg. Now we need to find our theta. Okay, theta, you can actually find your theta initially. you can actually find your theta earlier. It's 30 cm here. Okay, here is 30 cm. So this is basically the radius. 30 cm is also here, is also here. So this is basically the radius of this hemisphere. Okay, the radius. So this is your radius, 30 cm. And this is the radius for the circular motion, 15 cm. So we want to get the angle at this position. So basically, if I write down here is our big R, then we can have an equation. It's sine theta is equal to 15 over 30. Okay, then finally, using a calculator, you'll get your theta is 30 degree. Okay, your theta is 30 degree. Now we substitute the values. Okay, let us continue. So tangent 30 degree is equal to v squared. Our R is equal to 15 cm. You need to convert into SI unit. G is 9.81. Then you do the calculation, square root the values. Then finally you'll have V is equal to 0.92 meter per second. Okay, thank you very much. That's all for week number 9.